These are talks by engineers for engineers. We're going to go into some bunch of interesting topics. We always go into a bunch of interesting topics. This week's topic is how we do faster bootstrap from the nearest replica. That may be a mouthful, but it's quite an interesting topic. And I have Basava here with me to talk about it. And Basava worked on the feature. So maybe Basava, take like a minute to introduce yourself and where you're based out of and etc. And then we will get this show underway.
Sure, I'll get started. So hello everyone, I'm Basava Kolagani, and I've been working at Yugabyte for almost about a year now. I work remotely and I'm based out of Bentonville, Arkansas. Yeah, prior to my work experience here, I did my master's back in University of Wisconsin-Madison. As a software engineer on the CoreDB team, I got to work on a couple of interesting projects, one of which we'll be presenting today. We'll be going over faster bootstrap from nearest replica.
Awesome. Thanks. So, hey, folks, don't feel shy to ask questions. Just drop it in the LinkedIn comment box. You can join our community Slack as well, yugabyte.com/Slack. But yeah, go ahead. Yeah, go ahead, Basava. Take us through what is this about?
Sure. Yeah, so I'll just do a quick overview how tablets are created, how tables are partitioned and everything, and then jump right into remote bootstrap. So by now we know that tables are split into tablets, and tablets are replicated across nodes for high availability. And yeah, this slide as well, we show that there are replicas of tablets that are split across nodes, and then all these replicas together form a raft quorum. So they pick a leader among themselves, which coordinates all the user operations and stuff. And even if any of the node goes down, the leadership moves, and then there's no hit on the availability. So there's and then that's why we use the highly replicated raft quorum to process user operations.
So one question that comes up often, right, that might just maybe you can address in the previous slide is like using Raft to do the replication, right? What is special about using Raft as opposed to regular sync async replication that people use? Like, is it the availability, durability guarantee? What does it give? Why use Raft?
Yeah, so Raft is like, I mean, it's proven state of the art for maintaining all the leadership quorums and stuff. In YugabyteDB, we always ensure high consistency guarantees, and that we also make sure that all the operations, the write operations and read operations, are processed by the leader if we want strong consistency guarantees. And hence we use Raft for fast leader elections and also failure detection. Say your leader goes down. The new leader election happens very fast with use of this Raft stuff. Also, and then the new election happens, and the new leader is like very well ready to serve requests with no downtime. So that is one of the reasons, like zero downtime.
Oh, that's great. That's a bunch of reasons, right? So I think to recap, it's built-in leader elections, very fast failure detection that's also built in, no split brain, anything. You will guarantee data consistency, correctness, irrespective of the set of failures, right? So that's really the gist. Okay, got it. And yeah, I can keep going. So now, in horizontal scalability, you're going to talk about adding a node to that tablet to change the set of nodes that are participating. And this is pretty useful even to scale out or upgrades or changing the machine type, bunch of different operations, right? Okay, got it.
Yes. Say we have like an RF3 cluster, and initially there are 3 nodes, and then we added a 4th node. So now we want to rebalance the load across all these 4 nodes. So temporarily what happens is the replication factor for a few tablets goes from 3 to 4, and then you end up replicating those tablets on the new peer. So this is when your remote bootstrap kicks in. You have a new tablet peer on the newly added node, which is required to catch up with the most recent state of the tablet. And then this new peer remote bootstraps from the leader currently, but yeah, we'll talk about a few optimizations.
So a couple of details here. So in traditional relational databases, like, if you're using Postgres or Oracle or some of these, the failover is like, the scale out is not seamless, right? You have to know which node to add, whatever. So in this case, your data is split into tablets, and we figure out how many tablets to move to the new node automatically. And you are looking at one such tablet moving, correct? That's the view here.
Yes.
Okay. And the second thing is like for NoSQL databases, to populate the data here, you will have to go read the data from the other nodes, and you'll have to read through the database. So if you have a lot of requests going, it will increase the stress on the cluster, right? So here you are not reading the data, you are copying the files, and Raft will ensure that it is consistent, correct?
Yes, yes. And all this while even remote bootstrap is happening, there is no real effect on the leader. The leader still serves reads and write operations and everything is seamless. Just that RBS happens in the background and we won't notice much of a difference.
Got it. Okay, fantastic. Okay, let's keep going.
Yes, and yeah, as I said, this process of the newly created peer catching up with the most recent tablet state is what we call as remote bootstrap. And say once you have like four replicas for a few tablet peers, like, and you want to remove a particular node, the master will kind of ensure that all your tablets have three replicas on the existing three nodes, and only then process the remove operation. So none of your replication factor or nothing will take a hit. Also, the user ops still continue to be served by the leader. And yep, all we wanted to highlight is like there's still no downtime and there's continuous processing of user requests. I'll just move on to like what really happens in the process of remote bootstrap. So once your master once your master adds a new peer to the leader's consensus state, the leader will start heartbeating against the new tablet server where the new peer is supposed to be. But on the first heartbeat, it'll realize that the tablet is actually not there, and then it'll instruct the new peer to undergo remote bootstrap. Upon this, the new peer will start a remote bootstrap session. And this is a bit more detail on what happens inside remote bootstrap. Once your new peer starts a request to fetch data, the leader will take a snapshot of all its SSD files and also anchor the logs so as to prevent garbage collection and stuff. The log chunks are necessary for the follower to build up its state on the received snapshot of the SSD files. So that's hence the leader also logs the anchor on the walls to prevent garbage collection. Also, as I was saying, while remote bootstrap happens, you can see newer wall chunks being generated because the leader is currently serving read or write requests. Once you fetch all the SSD files, there is propagation of, we stream wall chunks, and also we update the anchor accordingly. And yeah, since you update the log anchor accordingly, the leader can garbage collect the older wall chunks that are no more needed. And once your new peer receives all the data, it uses this data to build its local state. And after it is done with that, all the while we maintain the log anchor, just a detail that we maintain the log anchor here. But once the new peer is done initializing its local state, it raises a request to end the remote bootstrap session and promote itself to a voter. That is a healthy follower. And yeah, so moving on to what our problem is, as of YugabyteDB version 2.18, the bootstrap always happened to be served from the tablet leader. So this might not be always efficient in a cross AZ setup or a cross regional setup. So we would be far better off if the remote bootstrap happened from a geographically closer peer instead, as opposed to a peer that is so far. We will be kind of leveraging the network topology, and the RBS will be much faster with reduced network costs. So that is the motivation of our problem. And yeah, taking just a pictorial look of a problem, if your new peer is being added to a follower that is close, say in the east, instead of bootstrapping over this slower link, we could just bootstrap over this faster link and simultaneously propagate the log anchor information to the leader. The leader will need to preserve the logs, because the follower will need to later catch up with the newer updates. So this part is kind of important, but yeah, most of your work can be done by fetching from the follower instead. Just a flow diagram of what the new approach does. Yeah, the new peer just contacts the nearest follower, and then we asynchronously we update the log anchors from the follower to the leader. This asynchronous updates don't add inline latency. That is the important thing to note. And all your data is fetched over a faster link. And yeah, I think we can go to the demo part. Let me.
Okay, there is one question from Sricharan Sirpa, which is what if the follower is down for some time and got back after a few minutes? How does it behave? So
Yeah,
when does this kick in?
Sure, let me just reshare the screen. There was some. Sorry, could you just repeat that question again for me, Karthik?
Question from Sricharan is, what if the follower is down for some time and it got back after a few minutes? How does this behave? So if it's a quick recovery from the follower, so it went down and then it came back up, what happens?
Okay, so we have this time window where we consider a follower has failed and unavailable. If it crosses that window, the window is like 15 minutes. If the follower is less than like if the follower is down for less than like 15 minutes, all the leader peers corresponding to the tablets the follower hosts won't kick out that node from the quorum. So if it is less than 15 minutes, and if it comes back up, the leader will just serve the newer updates from the wall and the follower will catch up. But if it's more than like 15 minutes, the leader will kick out those peers from the quorum. So even if the follower comes back, it'll realize that it is no more a part of that quorum, and then it'll self-delete the tablets, it'll tombstone the tablets. And then the master will, in the background, realize that the RF has gone down for these particular tablets and asynchronously create newer replicas on the existing live nodes. So yeah, it is all.
So I think the idea is you want to determine, is it a temporary failure or a longer permanent failure? If it's a permanent failure, you can copy the data somewhere else. But if it's a temporary failure, you have other copies, you can still continue to function with no problem and wait for this to come back. So you don't need to unnecessarily copy, right?
Yes. And hence we have that period where we wait for like 15 minutes so that if it's a temporary failure, the node will come back up and catch up.
Awesome. Yeah. Hope that answers
Uh,
next question. Let's keep going. Yeah, let's look at the demo.
yeah. So I'll just start the I'll just start the process and then walk through the setup. Just give me.
Okay, so you had some nodes that were down, which said
Yes.
stop. Now you're starting them. So it's like it's like you're adding the node now.
Yep. So I'll just move this to full screen and explain the setup. So I have like a cross regional cluster where my preferred leader is in US West and the other two nodes are in US East and in different availability zones, 2A and 2B. And I had this node down for like more than probably half an hour or so. And then now I'm just starting that node back up. And the universe on the right is the exact same configuration, but just one detail is that the universe on the left is like does not have the feature of bootstrapping from the follower, while the universe has on the right has this feature. So it's like just a comparison of before and after. On both nodes, there's currently a workload running. You can see
No,
that
before we go there, one other detail, Basava, which is the in the node on the left, right? Like, what is the setup? Like, can we look at like where are the
yeah.
nodes? Yeah.
So yeah, doesn't load the map, but
Yeah,
yes.
that's okay. You can close it and just show as it is. Yeah, you can just close you don't need to. Yeah, we can just take a look at the setup as it is. You can go to the nodes page actually. You don't even need to come here. So, okay.
Mhm.
So you look at like East 2, West 2, and East 2. So two copies in East 2 and one copy in West, and the West is the leader, correct? And
Yes,
it's
West is
the
said to be
same
the leader.
setup in the other side.
Yep.
Okay,
The
got it.
exact same setup over in this on this side as well. I
Okay,
have
so
the
East
preferred
2,
leader
West 2,
set.
and West 2 is the leader. So in both these cases, you are taking down one of the East nodes and bringing it back up. In the first case, it's going to copy the data from the West Coast to the East Coast, right? Because that's where the leader is. In the second case, it will choose the nearest location, which will be the other east node, and copy from there.
Yes, in the second case, this newly added node should ideally be copying data from this node as opposed to the leader, because we have the feature enabled. And in the first case, since we don't have the feature, the RBS will happen from a far-fetched node,
Got
which
it.
is the preferred leader in the west. And
Okay.
hence, like what we will be eventually seeing is the copy over here is slower than the copy over here.
Got it. Okay.
Let's just check if, and I also have a couple of I can show where the bootstrap is being kicked in from. I'll just wait for the T server process to start up so that I can walk through. In this case, in this universe, since the feature is off, all the remote bootstrap sessions would be served from this leader. We can we can see the
So you're
bootstrap
on which
session.
node right now? In the okay, yeah, we'll take a look at it after. Yeah, okay, yeah, we'll take a look at which node after. But yeah, let's wait for it to start up. Has it starts? It's pending. Okay, got it. And what about the one on the right? It's also starting up, I'm guessing.
It's also starting up. Yep. Yeah, this has started up. So I'll just, yeah, we can open
You are
this.
going to the node on the west coast, so the far away.
Yeah, I'm opening the node on the west coast, and we can see that all the remote bootstrap sessions are ideally served from this node.
Yep.
And on the if we take a look at the universe on the right,
it's already done. I'm guessing it's too far.
let's hope. If I open,
It's probably it already finished, I'm guessing.
just check. Yeah, in this case, the bootstraps are served from the nearest node, which is sitting in US East.
Yeah.
If you want to check the T server page, maybe it'll
Doesn't
okay. I just got logged out, but yeah, let me just log back in. Yeah, it doesn't have these remote bootstrap sessions.
Yep.
And then if we could also as well see, like on this on the new node, we could see like where the bootstrap is actually happening from as well. So I have a main table which is offer data, and then this particular, like, it has a couple of tablets. It is split into tablets, and okay. If we go to the tablets, I just want to show that. Yeah, it bootstrapped from the leader. It says that the bootstrap source was the leader and the bootstrap is now complete. While on this page, you can it says that it bootstrapped from a follower and the bootstrap is complete. So we could take a look at, we could just, since, yeah, I think most of the bootstraps are complete and all the tablets over here are in running state, we could just check the same over here. Yeah, I think all the bootstraps are now complete. We could just skip to the part. We could just list the tablets and then probably grab for the times.
So you're looking at how long it took to do the bootstrap. Yeah.
Yes, on the left, this universe is where we bootstrap from the leader. So it took about a minute each for all the tablets, I guess.
Yeah.
And on the right, if we do the same, Yep. On the right, it's like pretty fast where it's almost less than 30 seconds
Yeah, yeah,
each of the tablets.
yeah.
And if we just look at the averages as well, just for the sake of understanding, it's like 53 seconds on average on the left, while on the right, it ends up being 22 seconds. So it's like almost a fast, the half of the time that we bootstrapped from the leader. So, and hence we would, theoretically speaking, and even practically seeing at the results, we would be better off if we bootstrap from the follower instead of the leader.
Got it. Yeah, you'll make the topology aware decision, right? Whatever is closer.
Yes.
So
Yes.
one question that David Nolan has is, will RBS from follower get used during a rebalance when a tablet is just being moved between two nodes within the same region? That would be even better from a topology and latency perspective. I totally agree. So thoughts on that, Basava?
Yes, so this feature is enabled for all kinds of RBS. So even whenever you're kicking in an RBS, even for the tablet move or anything of that sort, it will always try to pick a closer node. The closer node might be the leader itself or might be a follower. So yes, even in those cases where you're doing tablet moves and reshuffling within region, it will still try to pick the closer node and be done in a faster and optimized manner.
Awesome. So David, yes, your ask is granted, it's true. Sricharan has another question.
Mhm.
It's quite interesting, which is faster bootstrap from the nearest replica, which means the nearest replica should be in sync with the leader node. What if the nearest replica lags?
Yes, that's a good question. So while picking this RBS source that is a non-leader peer, we also have a couple of other factors that we take into. We ensure that the follower is not very laggy behind. It is almost caught up with the leader, and the last message, the consensus message exchanges are successful, so that we don't just want to redirect the new peer to bootstrap from some follower which may or might not be live and stuff. So we have those factors well within consideration, and hence we pick a healthy follower for the bootstrap. Say, even though the bootstrap, after we initiate the bootstrap, the follower, the RBS source could end up lagging, we still have fault tolerance mechanisms where we still try that the RBS goes through, and hence we anchor the logs on the leader as well. So even if your follower was a bit back and your new peer caught up with that state, once the new peer reaches again, heartbeats again with the leader, it will fetch the newer updates. So there, in most cases, the RBS from the follower will go through. But if not, we again have a fallback mechanism. I was about to.
Yeah, but at a higher level, right, Basava? Like this is no different from, let's say there's no node add. Let's say a node goes down for like 30 seconds or some time and comes back up, a short period of time. Then when the
Mhm.
node comes back up, it is lagging behind the other two. It needs to catch up. So it will talk to the leader and say, look, I have updates up to, your update number 150. And the leader will say, no, I'm at 170. So you need the last 20 updates before you can join. Here are the last 20 updates. Apply it and come back. And once it applies it and comes back, then it can join back, right? So the same mechanism is followed. Now, the only difference is instead of going down and coming back up, you can assume this person, this new node copied from a follower that was at 150. It may have been close, it may have been far. Once it copies it over and comes back in, it'll ask the leader. The leader says, no, I'm at 190. I'm not even at 170. You need 40 updates here, take them and do it, right? So something like that. So it's built into the system anyway, right? Like it's not something new.
Yep, it's built into the system, but the point is that we'll need to, I mean, for the leader to preserve logs from
You have to
150
keep
and
that. You have to tell the leader,
yes,
to
yes,
keep something
and
extra.
that's what we do.
That's right. Got it. Yeah, it's great, great questions, Richard. All right, keep going.
Yep. And the fault tolerance and fallback mechanism that I was talking about, the RBS process is itself fault tolerant. Say your RBS source goes down during bootstrap or anything, the new peer will realize that, it's not able to fetch the data or talk with the node. It will tombstone the tablet and RBS will kick in from scratch. There's nothing that we need to explicitly handle. Everything is the fault tolerance mechanism is kind of built in. And since bootstrapping from a follower is a relatively new feature, we have a fallback mechanism where we fall back to bootstrapping from leader if we see that, there are like the bootstrapping from a follower failed for a couple of attempts, which is the value is controlled by this flag. So there is a fallback mechanism as well, since this is a relatively new feature. And yeah, let's talk about a couple of pros and cons of the feature, mostly pros, but yeah, we have one con as well. As I was saying earlier, this is a great benefit in cross-regional and cross-AZ setups. Also, say you have a preferred leader setup where you're performing scale-out experiments. For RBS, the outgoing throughput is like limited per node. We cap the total remote bootstrap outgoing throughput. So if you're performing like scale-out experiments where you're adding nodes closer to the follower zones, instead of sequentially bootstrapping from the leader, we would be far better off if we parallelly bootstrap from the closer nodes to the newly added node. So that's one setup where we could benefit from. Also, and since you're in YugabyteDB, since the leader is responsible for serving all the requests that require higher consistency, we would be better off if we didn't bother the leader with remote bootstraps and maybe ask the follower to serve it. So theoretically speaking, the leader would have more bandwidth to serve user requests as well. One slight con that we see with the feature is that, say you didn't have a preferred leader set. In that case, your leader peers are distributed across all nodes. But yeah, when you add a newer node without the feature, your RBS sessions will probably be distributed across all the nodes because the leaders are spread out. But with the feature enabled, most of the feature will kind of impose all the bootstraps to be served from a closer node. So it will place the RBS load on only one node instead of spreading out
All right,
the
but
load across.
this is kind of an edge case though, right? Like you need to have very few nodes in the cluster, and you need to have the leaders pinned to one of the nodes or regions. So multiple cases have to be true in order for this to actually.
Yes, and hence the pros outweigh the
Yeah, pros way
cons.
outweigh the cons. So making it a default is actually really good. You got it. Yeah. Okay.
And yeah, we have enabled the feature by default from 220 release onwards, and it is controlled under a G flag.
So the auto flag means you can enable it if you want to, but it will auto kick in 220.
Yes, once you upgrade from an older version to 220, the feature will be for the upgrade part, it will be disabled. But once you have upgraded and all your nodes are running 220 plus, the feature will be enabled by default.
Awesome. Fantastic. Okay.
Yes.
Other questions, folks? Anything else that folks have to ask? Otherwise, I think this was a great demo. I think this is amazing. The data set you picked, I think just shows 1 minute to 20 seconds, but I'm sure there are a number of users for YugabyteDB that are running massive nodes, right? Like many terabytes, like 20, 30 terabytes per node, right? In these cases, this is a life or death difference. Like you're trying to copy 30 terabytes from the West Coast to the East Coast versus inside the zone. That's a game changer, right? So, and that is happening in a lot of places when there's massive data sets and they're geo-distributed and so on. So yeah, I think this is a total game changer. Yeah. But other questions, folks? Okay. So looks like no other questions. So thank you. Thanks a lot, Basava. Fantastic demo. Really interesting and intriguing topic. It's just one of those simple internal building blocks, but no one probably stops to think about what happens, but a lot of details, right? So thank you for that. Once again, folks, if you have questions, you can continue to drop it in the LinkedIn comment box. You can join our community Slack as it shows, yugabyte.com/Slack, and go to the YFTT channel. And do start us on GitHub. We like that. But hope you enjoyed the talk. Thanks once again, Basava, for the fantastic presentation and demo. And see you guys in a couple of weeks, same place, same time, another topic. Okay, thank you. Thanks, everybody.